and welcome to EnerQuality's and buildABILITY's Housing Innovator Series. These are series that are free webinars. We're very excited to have Panasonic Canada here today. So before we start, I'm just going to have Michael Leo from buildABILITY say a few words. Michael.
Thank you, Shannon. Welcome, everyone. I'm so pleased that you could join us today. When I look through the registration list, I recognize many of the names, and I wanted to personally welcome everyone. Just a little bit of background. We're doing these Innovator series where EnerQuality and buildABILITY are running a net zero technology adoption pilot across the province. And we're working with some innovative manufacturers who are introducing their products, their net zero products, to the housing industry. We've got a group of 20 builders, and each manufacturer has pitched the builders, and the pitches have been terrific. And we thought that it was important for certainly the great manufacturers that we're seeing, and Panasonic, I'd put Panasonic on that list of great manufacturers. And we wanted them to share their pitches with the broader community. And seeing how we've done this already, we thought that we would offer this as a service to the entire community. So they're all free. And so this is a real opportunity to listen to the very latest technologies that are out there. And Panasonic has some new stuff that I'm sure is going to just pique everyone's interest. Today we're going to have Brian Pescod from Panasonic and Sunny Parada presenting to you, and we've also got Patrick Rooney, who's going to act as moderator, and he's got the switching slides. So without further ado, I'm going to pass it off to Panasonic. We will have a chance for some Q&A, so write down all of your questions. We want this to be interactive, and we want you to not hesitate to get any questions out there. Thank you.
I think Shannon's having connectivity issues, Edith.
Okay, so Shannon, so Adrian, did you want to say a few words about EnerQuality before we come back?
Sure, so we are Canada's #1 certifier of energy efficient homes. We do offer a lot of certifications that you can see here: Energy Star, Net Zero. We do offer a lot of workshops. You can always check out our website for more. And I think with that, let's just get right into it.
And I think the next slide is about us. Most of you know buildABILITY. We're a consulting firm, and certainly we've been focused on the housing industry for a long time and innovation adoption. And most importantly, we do offer training. Go on our website, and if there are courses that interest you, please sign up.
So,
Adrian?
yeah, so we do have a couple here. We're going to just go over the quick housekeeping rules. If you guys could all raise your hand and the function at the bottom of your screen, just to let us know you can hear us. Awesome. Everyone is muted for optimal experience. However, you can always type in your questions in the Q&A or chat. We will get back to them either at the end or throughout where applicable. So without further ado.
Perfect. Thank you, Michael. Thank you, Adrian. I'm just going to pop up my screen here, and then I'm going to pass it off to Sunny to start off some of the presentation from the Panasonic side. Is that showing up fine for everyone?
Looks good.
Yeah. Okay. Awesome. Thank you, Patrick. Everybody hear me? Can you hear me good, Patrick? Perfect. Okay. Thank you to EnerQuality. Thank you to buildABILITY for partnering with us on this webinar today. And I just really want to thank Patrick and the team too. We've done some good work on this presentation, and I hope you enjoyed today. And you can see high performance homes is what we'll be talking about, and how Panasonic can provide high quality solutions for basically houses that are built beyond code, or not only houses, but just residential buildings that are built beyond code. Next slide, please. All right, so agenda for today. Basically going to be the overall trends of high performance homes. We'll be touching on air source heat pumps, Panasonic ventilation overview, and then we will talk about our cold climate ERV, and then we'll give you a sneak peek on one of Panasonic's most innovative technologies on the market, NanoEX. And then after that, we'll have some time for some Q&A. Next slide, please. All right, so high performance homes. When we think of high performance homes, typically we think of these three things. So go beyond code. We look at going beyond code. We talk about, whether it's a better envelope, more insulation, constant and ventilation through an ERV or HRV, appliances, mechanicals, and smart features. When we talk about healthy living, we're looking at providing a high quality of life for occupants, and health and safety and comfort is definitely in the mix there. And then built to last is, homeowners these days are wanting houses designed to last a long time and provide long-term value and savings once they've purchased a high performance home. Next slide. All right, so our alignment. This is how we kind of align ourselves with the market in high performance homes. We want the house to live better, work better, and last better. So we approach the high performance homes with a value and comfort theme. So when we look at value, we talk about design. Those top three there: design, efficiency, savings, and increased resale value. And we look at how we can actually provide the customer with that alignment. And then when we talk about healthy IAQ, is I think where we can come in and really offer some value along the comfort, health, and safety of the people that live in the home. And then the durability and quality, we align ourselves really well with that based on our ability to manufacture equipment, and whether it's research and development and certain technologies that allow us to be leaders in the market. Next slide. All right, so right now we'll get right into it, and we'll talk about our product offering. But before that, I just want to give you an overview of my group. So next slide, please. Thank you, Michael, for the introduction. So I'm the National Sales Manager for HVAC Mechanical Solutions, and I belong to a group within Panasonic called Life and Device Solutions. You'll see that, there's no microwaves, telephones, and TVs in this group, but what we're focused around is really the builder market. Whether it'd be multifamily, it would be townhomes, it would be, builders that basically build any type of residential living. And where we'll be focusing today, and if there is any other questions when you see on the screen on all the other things, what we're focusing today will be the HVAC and the IAQ portion of this setup here. So I think next slide, I believe we're going to have a polling question.
There is a polling question here. Yep, I'm pulling that up now.
So for this polling question, we just want to gauge someone's knowledge before getting into some of the products. So the question is how many air source heat pumps do you think were sold in Canada in 2019?
Well, that's live. That's pretty good.
Okay, so
my screen seems to have gone black. Sorry, Adrian.
That's okay. If there are connectivity issues, I think I can pull it up on my end. So did you want to stop the screen? Are you able to stop the screen share, or do I have to?
My entire screen is black.
Okay, I can.
The polls are closed.
Not yet.
Okay, so Patrick, I have the presentation up. Sunny and Brian, when you just want me to go to the next slide, and we do have the results that came up. Sunny and Brian, I don't know if you want to speak to them or if you want me to say something.
Well, I can talk to them. So we can go to the next slide. So the polling question was how many were sold in Canada in 2019? And the answer is over 175,000. So 5 of you guessed correctly. And that statistic is kind of nice to see because it's a 15% growth over the last 5 years, according to AHRI. And it's good for me to see too, because my first project I did in 2011, when air source heat pumps were really less unknown than they are now. It's good to see that they're constantly gaining market share. So over 175,000 units were sold in 2019. And if we project that out another 5 years, you can just see the numbers climbing 15% a year. So in the market demand in Canada, it's going up drastically. So can we get rid of that? I see it on my screen. Oh, it can. Good. Okay, so why air source heat pumps specifically? The reason that we are looking at air source heat pumps as a solution is you can actually change to a net zero combustion, high performance home with an air source heat pump. And this allows you to shift towards electrification, which is a term we constantly are hearing more and more in the design world. And what that means is you become the ability to become a more self-sustaining entity of your home, business, or wherever you want to electrify. So when you add air source heat pumps, they're really good bedfellows with solar panels. And when you combine those two together, you can actually neutralize in a lot of cases your heating and cooling costs completely. And so that's a really big advantage of going to the air source heat pump is you can do on-site generation and neutralize your cost of heating and cooling. Next slide. Okay, so we're going to talk first about the outdoor units and then the indoor units. And basically, sorry, just one sec. Basically, our sizing will be predicated on your heat load calculation for the outdoor units, but so we range, and we're very versatile in our design. So we range from 3/4 ton in the outdoor unit all the way up to 4.5 ton, and we can go bigger as we chain them together and do different strategies. But for the most part, our residential lineup, typically we don't go over 4.5 tons. You really don't need it. And the indoor units will match that to the capacity of the outdoor unit. And we'll get into the outdoor units first, and then we'll get into the indoor units and kind of go through why you're really going to enjoy the word versatility when you start to hear this terminology more in the design world. Next slide. So the basic design premise is to do your heat load calculation, and we take that and match it with the outdoor unit. And then once we have the outdoor unit sized correctly, we can start to get really creative with the indoor unit. And what I mean by that is we can start zoning out these units. You can go to your basic one zone design all the way up to some of our units have the ability to attach to 9 indoor units. So that becomes really advantageous when you're starting to get into these energy efficient designs. You're going to hear zoning a lot, and that is a really key thing to hone in on so that you can control each zone separately instead of a complete house. And that's important when you start to really look at energy efficiencies. Next slide. So, oh, there we go. So one of the things to note here is, according to the building code, you have to meet, your HSPF has to be 7.1. Our units range anywhere from 8.3 all the way up to 10.5. So we easily cover that and then some. So our heating heating season efficiencies are easily covered off by the building code. We're well above that. So that's the first issue that I just wanted to address. And then the second one is, when you look at these zones, the outdoor units, we have a 1.5 ton system. And then people often get confused that we have two 1.5 ton systems. But the reason for that is the outdoor capacities and the ability to add more zones to this. And so if you look at the top unit, it's a 2 zone with a 1.5 ton capacity. And the bottom one is a 2 to 3 zone with a 1.5 ton capacity. But if you look closer, you can actually see the cooling and heating capacity in the bottom unit's a little higher. And the reason for that is because we wanted the ability to go in to a lot of these ones are really good for townhomes and apartments and condos. And so if we needed to do multiple zones, we just bump up to the 2 to 3 zone, and we can actually now put 3 indoor heads in one design scenario. And then we can step back and do the 18,000 BTU or the 2 zone 1.5 ton system for a more simplified system that needs that much outdoor heating and cooling. So go to the next slide. So the next one we get into for the outdoor zones is a 2 ton and a 3 ton. And as you get your heating loads increased, we have the ability to actually put in more zones. So if you want to add up to 5 zones on a 3 ton system, you can do that. And that's kind of where we get into situations where you can't provide a lot of ductwork and you need to put just the refrigerant lines and an area that is basically without ducting, and it's just recirculating the air, heating and cooling. And one scenario we ran into that was a high-rise townhouse, or really dense townhouses. And we had 2 ducted units on the main floors, and they couldn't get any more ductwork through to the top floor. And so the refrigerant system we used, only 1.5 or 2 inches total piping that went up to that top floor. We put a ceiling mounted unit in and recirculated the air so we could provide heating and cooling without the actual ability to get ductwork there. So once we get out of the mini splits that are really good for the smaller houses, townhomes, and apartments, we get into the bigger units. Next slide, which we call our EcoEye VRF. And this is where we get into some really interesting scenario designs and ability to really take the gloves off, so to speak. And you can see here that we can actually connect up to 6 indoor units on this 3 ton system. And when we get into the really big designs and we get into the custom homes, we rely more on the next slide, on the 4.5 ton. And again, you can see the HSPF is 8.3. We're still code compliant. And we have a 4.5 ton system here, which goes up to 57,000 BTUs. And again, you typically won't have 9 indoor heads connected to this in a residential scenario, but we do have some commercial situations come up where you do have that. It's very rare, but it does give you the ability to do 9 indoor heads. And as you get more complicated designs and get more zoning, this becomes a very useful tool to do. And like I said, it's not as much in the residential, it's more for commercial. But when we get to the real large custom homes, we just finished one this summer that was 10,000 square feet. We actually ended up putting 2 of these units and zoning 1 floor and half of the upstairs on 1 unit, and then the basement and the other half of the upstairs unit on the other unit. So we could get up to 10,000 square foot homes with 2 of these units and zoned it out really nicely. So it was a really interesting scenario, but we're with the power of these connections in the indoor units, we have a lot of design capabilities and versatility. So now we get into the indoor units, and if we go to the next slide, we have our MVA unit, and this is more traditional ductwork design. So you'll see it in more of a scenario where you don't want to change your ductwork, and you just want to keep with a single residential home, and you want to keep the same ductwork or a townhouse, and you don't really want to zone out the townhouse or the house in itself. This becomes a 1 zone system. So we match the outdoor unit, we match the indoor unit, and then we just basically move forward from there. It does come with a backup heater, 3 to 10 kilowatts, which is optional. For the most part in Ontario, I do recommend to put that in there for the cost. You do have the electric backup. And it comes with an ECM motor. And this is key in all of our designs, and why we can have so much efficiency is the outdoor units and the indoor units, the capacities range from 30% that can go all the way down to 30%, all the way up to 130% of the rated capacity. So when you hear 5-stage, 3-stage, 2-stage, this essentially becomes, if you need 37% of the energy out of that unit, it gives you 37. If you need 82, it gives you 82. So it gives you exactly what you need between those 30 and 130% ranges. And so that's a very important key in really being able to control the energy use. So you're not going to 1, 2, or 3 stages. You essentially have 100 stages. Quick math there, 30 from 130. So when you have a traditional zone, next screen down, what I mean by that is, next slide. So here's where we're talking about matching your heating load. So if you have your outdoor unit, you need 3 tons. We put 3 tons on the outside. We put 3 tons on the inside. And this is what we call traditional ducting. And we can basically supply and return like you normally would. So if you have your current designs this way, we can just slide this right in there and continue on like it was, there's no real difference in your duct layouts or duct designs. As we get into more zoning, and next slide, we get into our slim duct lineup of the indoors. So these systems are really good in our condo and apartment designs and townhouses where you have a hard time getting ductwork up and down floors. And it really works out well in the residential single dwelling design as well, because what we do with this now is we start zoning out each floor with one of these units. So as you can see in the drawing there, we have the return duct on the bottom right-hand corner, and then you can supply it with either 6 or 8 inch duct to multiple locations within that floor. So we can actually start designing these systems so that you can have different temperature zones inside the home. So if you go to the next slide. So this is what we would call our 2-zone system. And what we do is we put a 3-ton unit on the outside, and you'd put a 2-ton unit on the main floor. And this is just for simplicity. But so basically you have that 2-ton system on the inside. 1 ton does the main floor, 1 ton does the basement, and then you have another system on the top floor that is a separate zone that does 1 ton. So you have a 3-ton outside and you have a total capacity of 3 tons on the inside, but you get 2 zones. And what's important about that is if you're not home or you're not upstairs, you can actually set back those temperatures now, and vice versa. If you're upstairs and you're sleeping, you can put it at a comfortable range and set back your main floor and your basement. And then we can go another step further and go to the next slide. And we get into the 3-zone system. And the ability to be able to control every single floor temperature now. So you get a thermostat control on every floor, and your 3-ton unit now is supplying heating and cooling to every 1-ton unit you see there. And so now you can have 3 different zones with 3 different temperatures in it. And that's key because we all know, like for myself, in a lot of applications, I don't go in my basement very often. Since we're empty nesters now, we don't really go in there a lot. So for me to set that back to 18 or even 16 degrees Celsius would be very advantageous. And I just need to keep it above that 16 degrees Celsius. On the main floor, 21C. Top floor, depends on when you want to actually set it. You can back it off, ramp it up and down as you see fit. But what this gives you is the ability to control each zone. And that's a huge key to being able to have the energy efficiency in the house actually ramped up to get to the next level of controlling to net zero, zero combustion, smart homes. This is the next generation. This is the next step, what I think is going to be a common design moving forward. Next slide. So when I say versatility of our indoor units, that whole outside circle you see there is all our indoor units. And so when I say we can connect up to 9 heads, you can put a lot of different combinations together. So you see there that on the bottom left, or just 2 up from the left, I guess that's like 8 o'clock, you can see the slim duct unit. And then below that, we have the medium ducted units. And on the right-hand side, getting closer to 3 o'clock, we have our wall units. We have ones for vestibules, like for radiators. And then we have our ceiling units. So when we start to combine these, there's very few situations where we can't come up with a scenario that we can heat and cool a space separately and start zoning out these different areas. So it's really advantageous to be able to have the air source heat pumps that have a lot of capacity matched the indoor design. So it's, when we do say you need a 3-ton system on the outside, sometimes we've added an extra half ton because we've had clients that say, well, you know what, I wouldn't mind heating or cooling my shop or my garage because I work in there a lot. So we end up saying, okay, well then you just upsize the outdoor unit a little bit and you throw one of these in it, and you can, the wall unit in your garage, and you can heat and cool your garage or your shop. So, and again, if they have a space over the garage, we're seeing that in a lot of designs now where they have, where you actually have a living space or an in-law suite, whatever you want to call it. Now you can heat and cool that all from that outdoor unit. So it just really starts to push that interior design and zoning control to the next level. And then lastly, like I said, next slide. Next slide. Leads us to adding solar panels and batteries. So when you get these zoning, the ability to start zoning these energy loads out and reduce them, now you can start zeroing out by putting solar arrays on there and using battery storage. And then again, that's the next level of what I see coming down the pipe. And if anyone's interested, we can give you a link after, where Fujitsu, a town in Japan that Panasonic built, called Fujitsu, or Fujisawa, sorry. Jeez, that was terrible. Butchered that one. Where they actually did 1,000 homes like this with this exact design, and that's been operating since 2016. So it's not something that we're trying out or testing. This is something proven in our technology, and we've been doing for quite a long time in Panasonic. So now I'm going to briefly go through the ventilation. Next slide. So we have a lot of options, obviously. You can see here, we have our entry market levels in the Whisper Value up on the right-hand side. Then you can start upgrading to the Whisper Green. And basically what we can start doing is adding different components to this, like motion sensors. We have light sensors. We have on the left-hand side, you can see the Whisper Warm, where we can actually provide heating. We had one scenario where somebody had a bathroom that was cold, so we ended up putting the Whisper Warm in there in the basement apartment, and it actually heated up the bathroom for them quite nicely. So we have a lot of solutions and a lot of different scenarios that we can address. We have a lot of different sizes, and we have a lot of different versatility. Again, same with our air source heat pumps. We really try to solve all the indoor air quality problems by offering a lot of different products here. And I won't go into every single one, but we definitely have, like I said, the Whisper Value is very key to coming in at comparing with everyone else in the market for entry level. And then we can get all the way up to adding LED lights, motion sensor, moisture sensors. A lot of times when kids go in the bathroom, they don't bother flicking on the fan. So when they jump in the shower, this will sense the moisture level, kick it on automatically, and that'll keep the moisture levels down in the bathroom. And next slide. All the bathroom fans are manufactured within Panasonic, so it's their proprietary engineering and design, and that is why they have such a high level of quality in them. They're not third party, they're all Panasonic and designed in-house. So the same level of engineering and QC that goes into our air source heat pumps goes into our venting. And a lot of the technology is DC driven, which also reduces the noise level. And someday when we get you all into the showroom again, once we get through this little pandemic, not little, sorry, but once we get through this pandemic, we'll get you into the showroom, because a lot of times what I do is before people come into the little area we have where we show everybody the equipment, I turn on all the bathroom exhausts, and there's 5 in there. And during the whole presentation afterwards, they come up to me and say, well, let's hear what they sound like running. And I tell them it's been running the whole time. And that's how quiet these systems are. You actually have to put your hand up to them to make sure they're actually exhausting air. So they're extremely quiet. A lot of them you can pick a flow. We have that ability to start ranging in and out of CFMs, which we're getting more and more desire for that as we get tighter houses. So we're going to go into another polling question. Yes, no? Okay, there we go.
Sorry about that. Yeah, it just launched.
Do you want me to read it? I don't know if anyone's...
Okay, so before we hop into the next section, we just want to test your knowledge about ERVs as well as HRVs. Just to understand if you know the main differences.
So it has been a minute. I think I'll end it there.
Okay.
Last second, share the results.
Oh, that's excellent.
We have some experts in the audience.
Yeah, love it.
Okay. So yeah, the correct answer was the ERV has the ability to transfer moisture. They help prevent excess dryness in the cold season and reduce the demands on the air conditioning system in the warm season.
Okay, great. That's good news. So the strategy behind the next one is we didn't bother. Panasonic doesn't make an HRV. They just went straight to the ERV because they want to do the complete moisture transfer, and you get a better performing product. So if we go to the next slide. So what they did was, oh, next one after that. There we go. So what they did was make a cold climate ERV. And what that means is that it'll operate down to minus 30 degrees Celsius, and it goes into defrost cycle a lot less than the competitors. So that's a huge bonus when you're trying to do energy efficiency design and trying to capture as much of that heat loss or heat gain out of the ERVs. So a lot of times when you get other products, what they'll do is they don't go into defrost mode. They actually go into a bypass mode at minus 30. So anything below minus, a lot of them at minus 15 will go into a bypass mode. Ours will still operate in defrost mode down to minus 30 and still give you about 60% of the energy transfer. And that's pretty key because that's when you're going to want that energy transfer is that low temperatures. And so the advantage to our system is the cold climate is actually rated, I think, to zone 4 in the ASHRAE guide to heating and cooling systems. But the other thing we can do is pick a flow technology. So this ERV comes with 2 DC motors, one for supply and one for exhaust. Now that's very key to balancing out a house's ventilation system. And so what you can do is range your supply from 50 to 100 CFM, and your exhaust the same way, 50 to 100. So they're separate. And so that's key in scenarios where you want to add more or take away some more exhaust. And there's a bunch of scenarios that we run into where that situation is key, because a lot of the motors with one will either exhaust 60, 70, 80, but then they supply the same. And so a lot of times you need to supply and exhaust different numbers. And so you can actually just adjust that on a setting that you see in the top right hand corner in the ERV. There's a little white rectangle there. And if you go to the next slide, this is what it looks like. So you can actually go in there and adjust your own supply and exhaust. And then you also have an ASHRAE 62 timer. It's just a fancy way of saying how many minutes do you want it to run at full capacity per hour. And you can adjust that from 10 minutes up to 60. And there's multiple strategies behind that. So if you want to actually run it at 50 CFM continuously, and then you want to put in the boost control and tie it to your bathroom, that's one of the things you can do. Or if you know that you only need to supply a certain amount of CFM per day in each hour, you can actually ramp down your ERV to match your settings of the required CFM. And again, this is all honing in on getting more smart controls and understanding the energy level that we need to get to that zero combustion, net zero Energy Star goal. So if you go to the next slide, this is very new. Like this is just literally hot off the press as of like, I think 2 days ago, I found out that we finalized this. So we partnered with a team called Swidget, or a company called Swidget, and they're based out of Kingston, Ontario. And what they have is a control device for us that you can actually set 20, 40, and 60-minute timers. So that ashtray setting, you can actually set in a wall switch now. So you can actually have the function of whatever you want. So if you're going to use it for your boost in your bathroom, you can actually control that now. Very important in apartment and condo settings. And it's very advantageous when we start sectioning out airflow. I think one of the things you're going to hear a lot in the upcoming months about COVID is dilution by solution, or solution by dilution. So they want to basically start zoning, not only zoning out your heating and cooling, but zoning out your ventilation. And so having this kind of control system is going to be very key into reducing mold, bacteria, viruses, etc. in your home, because you want that fresh air coming in, but you also want to be able to control it. So when you're not home, you want to be able to ramp it down and then ramp it up. And so you actually have a Wi-Fi controller in this. So if you're not home and you know you just need to provide 50 CFM to your house, you just basically ramp that down from your phone app. And then it also comes with a temperature, humidity, and motion sensor. So again, when you have young ones that go into the bathroom and they don't bother turning on the fans, this will automatically kick on for them in the boost fan mode if they're using it for the bathroom, and then the motion sensor as well. So we're really excited about this. It's all controlled by that little green space in the Swidget. The guy from Kingston he worked with NASA for I don't know how many years, but I don't know how they can get all that technology in that tiny little device. So we're pretty excited to add this control system to our lineup in our ERVs. And then lastly, the next slide is again, we brought this into Canada with -30 in mind, cold climate. It's the most effective in the industry, and I'll show you how we stack up against everyone else in the next slide. But one of the other options is I didn't want you to go there. So one of the other options is going from a MERV 8 to a MERV 13 filter. And that's going to be another key thing when you talk about nanoparticle sizes and filtration systems on your ventilation. Not a lot of systems can power up and ramp up with a DC motor to supply through a MERV 13. It's very critical to remember that. So if you have like a plastic flimsy filter, it's very easy for your static pressure to push air through and ventilate. When you put a MERV 13 filter on, that's going to be harder on that engine. So a lot of the ventilation fans out there can't even do that. They can't go to a MERV 8. We can go all the way up to a MERV 13. So that's important, knowing what's coming up next in the ventilation designs and the guidelines we're seeing from ASHRAE 62. And you're going to hear dilution as a solution over and over again for the next 10 years. I guarantee it in the design world. So how do we stack up against everyone else with our ERVs? Next slide. Very well, if I do say so myself. So when we look at some other competitors, the one area we like to compare to is, and you'll see in the building code, is they'll reference sensible recovery efficiency at 0 or 32 degrees Fahrenheit for our American friends. So what you see is we come in at 81%. Ours is the cold climate on the far left. And as you go right, the next closest one is 69%, and then they drop off to 67, 66, 63. So that 81% is very key. At 0, we're still bringing in 81% of the outdoor heating or cooling and transferring it to the indoor air coming in. And I think everyone that answered the ERV question knows a great deal about ERV, so I won't go too much into that. But the other thing I'd like to note is if you look down the efficacy, which is the CFM per watt. And that's important, again, when we're talking about energy. It's like how many miles can you get to the gallon or kilometers to the liter? So our CFM per watt, we get 2.21. The higher the number, the better. So we get for every 1 watt, we're getting 2.21 CFM out of it. Our competitors, the closest one comes in at 1.2, then we drop off to 1, and then you get down all the way to 0.58. That's the key number, because when you're pushing through a MERV 13 filter, where you can see that some of these aren't even, from these ones, I don't even think there is one that does a MERV 13 filter. But when you're pushing through that MERV 13 filter, it's going to cause a lot more energy draw, and ours still comes in at a higher rated of 2.21. So when we stack it up against anyone else, it's pretty obvious that ours is designed for the cold climate, and it's the choice that I think you should be making when you move forward with an ERV.
And before you move on there, Brian, I just as a visual note, when you look on top along all the ERV pictures, keep in mind the slim design. I mean, you see how ours is really like almost like a slim duct unit, whereas everybody else is a square box. So, I mean, is it a big benefit? I mean, when you're designing and you're a designing engineer trying to do HVAC systems, it really does help. And then aesthetically, it probably looks better too. So just wanted to mention that.
Yeah, that's a good point, Sonny. When we do our slim duct design in the condo world, in the apartment world, that 9 inches, that in the ceiling spaces, you fight for every inch, just like a mechanical room. And that system is smaller than our slim duct. So it's really advantageous to have them the same size or smaller. When you get into the bigger units, it really becomes an engineering nightmare, or more of an architectural feature where you have to put bulkheads in to satisfy some of the larger ERVs. So, you know, with their experience with smaller units in Japan, they've really honed in on being able to make these systems fit anywhere. And that's with our ventilation, ERVs, and slim duct designs, is you're getting rid of a lot of that architectural features that you have to create bulkheads and try to sort out that whole mess. And it really helps with the design, overall design on the architectural side as well. Thanks for pointing that out, Sonny. I forgot all about that. So if we go to the last slide, you see that the standard air source heat pump warranty, 10-year compressor, 10-year parts, and then the ventilation solutions are on the right. What I like to say, I heard somebody say it once, was you're getting a 10-year warranty from a 100-year-old company. So that, I think, is pretty, stands on its own there. And the warranty is going to be around for a long time. This company isn't going anywhere. They put a lot of thought and into the technology. And having said that, I think we'll let Sonny take over and talk about the next level indoor air quality.
I just wanted to give you guys a time check too. We're at 11:43.
I'm almost on time.
Okay.
We're getting there.
Yeah. Take it home.
I can't seem to pop my video up for some reason. I'm not sure why. We'll go with it though. So yeah, next slide, Adrian, please. Awesome. So I was hoping, I mean, we're gonna spend a few minutes on, when we talk about new technology and sneak peek, some of you might have seen this, you know, this technology around lately as we've been promoting it in Canada. This is a Panasonic proprietary technology that was developed and has been in homes and several other places since 2003 across the world. I just wanted to give it a little bit of a background in nanotechnology. So it's a trademarked Panasonic unique technology. And we look at nano, and we talk about the origin of it. It basically, you know, we know where that comes from. We add the E, and that's how we get the nano E. And what we're going to talk about today is the nano EX technology, because there is a nano EX. A nano is the original, and the nano G is another technology that we use across the world. So I'm going to talk today about the nano EX technology. Next slide, please. All right. So we're really excited about. We know that you know, IAQ is sort of front of mind on pretty much everybody when we're in a global pandemic. But this is a technology that we were bringing over in March, before we even knew there was an actual global pandemic, you know, in front of us. So what we did is we looked at bringing the first piece of technology is an air source heat pump, a single zone cold climate heat pump called the Climate Pure. And you'll see how we kind of reflect that in the right-hand side here with the indoor wall mount unit, typically with an air source heat pump solution. And we also looked at other things. We're bringing it in a multi-zone, which will be in January. But I just wanted to go over a little bit about the technology itself. It's different than ones you're hearing out there. It's not a trapping, you know, trapping stuff. It's not filtering. It's really unique technology that we are the only ones that actually have it. So when we talk about nano EX, we talk about OH radicals, okay? And OH radicals are very, have a lot of hydrogen in them. And what we're looking at doing is, from the moisture generated in the air, we use this device, which you'll see in the next slide once I get there. And we create, believe it or not, 4.8 trillion nanoparticles or OH radicals per second. And when you look to the bottom right, you see the OH radicals engulfed in a water particle. And that's the key to our technology. So, you know, a nano is a nano, but nano EX, when we engulf it in a water particle, we have, it's sort of strength by numbers, and it actually gets into the air and is able to actively purify into the air and last long and attach to certain pollutants, what I'll go over now. So we do have benefits of Nano-EX here. I want to state that we are in talks with Health Canada, because the device that you'll see is registered to sell here, but we can only make so many certain claims about it. When we talk about odors, allergens, pollen, hazardous substances, and even skin and hair, believe it or not, which we'll see in the next couple slides, we do add, and we can point to bacteria, virus, and mold. And like I said, I'm not going to have it on this screen. We're not going to make the claims, but if you want more information, feel free to just Google Nano-EX, or we could provide you links that'll show you our global testing on various different types of bacteria, mold, and virus. So I'll leave it at that. 1, 2, 3, 4, 5 benefits, but there's actually 8. And if you want to know about the other 3, we can help you and direct you that way. Next slide, please. All right, so yeah, right there, that's great. Thank you. So top right, you see the Nano-EX device. It's really, essentially that's what it is, and it's tiny and it's powerful. We look at 4 needle shapes, and what we're looking at, if we go down the bottom of the screen where it's 1, 2, 3. So when I talked about moisture, really all you need is 10% moisture in the room for it to activate. And when we talk about the dew condensation that collects on the tip, what the key is here is we're providing a high voltage applied to that tip where that dew condensation is forming, and that's how our nanoparticles or OH radicals are generated. So essentially, you could breathe in the room and this will be activated. So when we talk about our air source heat pump and our single zone and multi-zone right now, it's in the indoor wall mount unit, and it can be run 24/7 along with your heating and cooling, or standalone as an air purification device. So not only can we provide heating and cooling, we can provide heating, cooling, and air purification. So that basically covers off all your comfort and safety needs. Next slide, please. How Nano works. So there's a couple things that we can talk about based on that screen we saw before. So whether it's odors or airborne and adhered pollutants, and we'll leave skin out of it right now. Essentially what we're doing is we're generating those 4.8 trillion per second OH radicals. And what we're looking to do is basically pull hydrogen away from all these odors and adhered pollutants. So you'll see here, it's not just an airborne actively purifying airborne particles, but we look at fabric and we look at the odors, and we basically, whether it's surfaces, we find that protein and we take the hydrogen out, and what we're left with is water in the end. So we're really doing like a death by, 3.8 trillion cuts, if you want to talk about it like that. And the nice thing about this technology is that once it comes out of that device and, let's say the indoor wall mount unit, it lasts for 10 seconds. So it'll find whatever it needs to find, but it'll spread and cover the room, for 10 minutes. Because it's engulfed in water, it protects itself until it says, you know what, we're going to spread and find every part of the room and every surface, every corner, and look where we could, take away odors, air, pollen, allergens, and like I said, in some cases, bacteria, virus, and mold. One key thing too is, I thought to myself, how does it help skin moisture? It even helps hair. You'll see it's a 28-day process, but the fact that you have this running all the time, you'll look at what it does and how it actually provides and hydrates the skin. I won't get into it too much, but if you need any kind of direction on this or have any questions, we basically can point you and provide you, whether it's to do with odors, pollutants, allergens, PM 2.5, skin, hair, bacteria, virus, mold. We can point you in a direction that will show you exactly what testing we've done globally across the world. So one thing I will mention, I'm not sure, the next slide is probably questions. But what I will mention before that is we're really excited about this technology, and we're working hard at bringing more products with this technology in it. And one thing that I will mention that we've actually confirmed is that in April, May of this year, we will be bringing the Nano-EX technology in a single generating fan. So if you want to think about, how can I explain this? If you want to think about a little bit bigger than a pot light and maybe like a speaker that you see sometimes in the ceiling with a register on it, we're going to have a Nanogenerator fan coming out in April, May. that will essentially basically take care of air purification. It doesn't provide heating and cooling or exhaust. It's actively going into the room and actually providing air purification into that space, and it'll do a certain amount of space. And obviously you'll have to get these in certain spots in your home and your, in your office. Right now we have some pilot projects going on where we're doing we've done a clinic, and also we're doing a showroom for a big developer to introduce into their big development over the next 5 to 10 years. So we're really happy and excited about this technology. It's a Panasonic technology. And if you have any more questions on it, please feel free to contact Brian, myself, Patrick, and we can provide you everything you need to let you know that this is the technology of the future. Thank you.
Awesome. So we do have a couple of questions that are coming through. So I'm just going to go from the top. The first question is from Mark, and he wants to know, he has an energy efficient home that was built in 2000 with a hydronic heating system with gas-fired boiler feeding into an air handler that is ductless. Could any of your units work with existing air handler and no ducts?
That's an interesting scenario.
Yeah, the answer would be no. If it's an existing air handler, we can't tie into that air handler with our outdoor unit.
Yeah, but you can actually add our units. Like where I have seen it before is a lot of hydronic systems that we'll work with is they'll put our unit in to do the top up heating and cooling. So if you're having a hard time keeping your home heated or cooled, you can add our systems to run with it. And so what we can do is actually top up the heating and cooling with our units. So I have seen it with hydronic heating, and we have done that before. And then it actually, what we do is provide 100% of the AC and then say 40% of the heating. So I don't know if that helps, but that's one of the scenarios we ran up against.
Okay, moving on to the next question from Susan. Which is the most airtight bath fan, and what is the design difference to make it more airtight?
That's more of an architectural feature. It's not what makes a bath fan tight, it's what you do behind the scenes. So we have a compression fitting between the drywall and our unit that are tight, but you still have to seal around that unit. So it's really up to how tight your drywall is, but you can also put a cover over top. I've seen where they've done it in ceiling designs is they actually put a plastic cover right over the lights and the fans. So it's our fans are pretty airtight, like as a component, but it's really dependent upon the architectural, how you handle the drywall too. So it's not just our bathroom fans. They're tight, they're not going to leak, but it's also the ductwork behind it. You should be sealing ductwork behind it and all the necessary things to make that airtight system.
And following that, can any of these fans be used if replacing a bath fan that is connected to a switch in the bathroom and a switch in the dining room, and also turns on if the fire alarm is activated? Are there any special concerns?
I would say I'm not a fire code expert, but my first concern is you don't want ventilation on in a fire. But I'm not going to address that. You need to talk to a fire expert, but no, our fans have their own control system. I don't think you'd want that. I don't understand why you'd want the ventilation to come on during a fire. It may be to remove smoke, but yeah, I'm not sure why, because if you have any ventilation in any other situation, you shut the dampers off, and that's the scenario to go with. But I would just say no at this point to simplify that.
Okay, the next question. Next two questions from Farsight Homes. What powers the new switch line? Is it a low voltage or line voltage? And is the communication to the ventilation fan wired or wireless?
So when you say switch line, I'm assuming you mean the Swidget system?
Yeah.
Yeah, so I would, that just goes into your plug or any 120 or one low voltage 110. It's just switching out. Instead of having your on-off switch, you just put that switch in. So it's the same configuration. And we do have wireless controls for various fans for ventilation and ERVs. It depends on which combination you're looking at, but we do have wireless and wired. I'm not a big fan of having too much wireless, simply for the fact that if you lose it, you do get stuck with trying to figure out how to control it.
Mhm.
I like wired personally, but that's just my personal preference, or both. Susan, what is the average life core of the ERVs, and what is the average life of an ERV? I'm not sure. Do you have an answer for that, Sonny?
What the average life?
Yeah.
I mean, it really depends, but we look at the warranty on it, and I would say, you know, like any piece of equipment, I mean, the core is pretty solid, but regular maintenance, I'm going to take a guess out there and say, you know what, 10 years should be, you know, if you're regularly maintaining, 10 to 15 years will work. You know what I mean? It just depends on how you maintain the unit.
And also keep in mind, when you add an ERV to your ventilation strategy, the payback analysis is basically 2 years. So after that next 8 years, you're basically gaining all that energy, and cost savings is going right into your pocket. So whenever we've done a cost analysis with ERVs, it's always been under that, like it's like 2.2 or 2.3 year payback analysis. So they definitely outlive their life at like that payback analysis. So they're definitely worthwhile to put in every ventilation scenario.
So the next question is from Jason. Have any of these systems ever been tested with alternate construction methods like 3D printed housing? And if so, how was their performance rating?
Our performance rating won't change in our equipment. It's all predicated on our heat loads that you give us. So how tight is your envelope? How good is your building? It really has no impact on our rating system for our equipment. Our equipment's going to act the same, whether it's a straw bale house, a mortar, brick and mortar, or a wood construction. Our systems are going to be heat and cooled at a certain level. It's really not impactful. The only thing that I can say is like, how good are your printed houses? And what are the envelope, or what does the floor door testing come back at? And that's going to be impactful on actually just sizing our equipment, not the efficiency. So if you have a leaky house or a poor quality housing, you're going to need a bigger unit to heat and cool it. The better your envelope is, the less size of equipment you're going to need. But our efficiencies don't change with your building envelope, just our size of equipment does, because your envelope requires more or less.
Okay, awesome. The next question from Dave. Does the Nano EX impact relative humidity?
No, it doesn't work that way. It adheres to the humidity in the room. It doesn't create humidity. Mm-hmm. So most homes have about a 40 to 60% relative humidity throughout the year. And the Nano X will basically adhere to that. Like Sonny explained, it'll actually go into that water molecule and then basically travel 10 minutes into the room wherever it's needed. And it doesn't affect relative humidity. So short answer, no. But we do need some humidity to make it work.
Okay, I know there are some questions that were given to us in the chat, and Patrick has been monitoring that. Patrick, if you want to address any of those questions.
I think, yeah, there's just one more here in the question and answer, and then I'll move over to the chat. The last one in the question and answer is ventilation fans that turn on. Oh, that's a comment for the fire. So the fire alarm in Ontario home built in 1998. I've seen this in many homes from that time period. So that's kind of answers towards the original question. I'll move over to the chat now. There's a couple that I had here that weren't answered. One that I answered, and I wanted just to share to the whole audience, is the Nano EX technology available in the multi-zone system?
Yes, it will be starting late January, early February. It'll be in the 19,000 2-3 zone that you would have seen in the presentation before, and it will also be available. The heads that will be available are 9,000, 12,000, and 15,000 BTU.
So yeah, and keep in mind, in Japan, this has been a product that's been in development for 20 years, Sonny?
Yep.
Yeah, so they have it in 850 different devices. They have it in cars, subways, elevators. So we're trying to bring over as much technology that makes sense for the market to bring over as fast as we can. And so we're working pretty hard around the clock trying to get these products through the testing, A lot of it has to do with just bringing it into Canada and the different requirements. And because they're different pieces of equipment, it's going to take us a little bit of time. But we're moving as fast as we can to get as many products, indoor air quality products here as possible. Yeah.
Thanks, guys. Sticking to the Nano EX, this question came in is, what is the maintenance cost like on these systems?
The Nano X or the air source heat pumps?
Let's go with both since it's a generic question.
All right. Well, if we're going to talk about Nano EX, when I showed you guys that the device, it's literally maintenance free. The only thing that you would have, so in our single zone heat pump right now in the wall mount, the only time you'd have to actually attend to it is if there was no power to the act. Because remember how I said we're applying a high voltage to that actual stainless platinum Peltier device, so the rod. So for some reason, if the electrical connection was somehow, came apart, then they would disengage the Nano EX, and it shows us by a blue little symbol and the word Nano EX on the actual heat pump. Then that would have to be there's an error code that comes up, and then you'd have to actually plug it back in. But otherwise, maintenance free, no filters, no checking on it, no cleaning on it, and it's actually it will outlast the lifetime of any piece of equipment that it goes into. So if it's the wall mount or the Nanogenerator fan we're bringing in, it's going to outlast that piece of equipment maintenance free.
Thank you. And kind of sticking to that, going to more towards, I think this is asking about air source heat pumps, but Sunny, do you have a payback ROI on this type of tech?
We do, but it depends on what kind of system you're comparing it to. So that's a kind of a loaded question, like it compared to what? And then we get into, are you comparing apples to apples? I get asked this question a lot in the residential market. What I usually say is go price out something with the same SEER levels and the HSPF levels that we have in our systems, and we'll come in cheaper than those systems. And a lot of people are shocked at that. They have a misconception that air source heat pumps are really expensive. They're expensive because remember, when you're sizing the heating and cooling loads, they're almost the same. So your furnace and AC units are the same size. And when you go out and compare a furnace and AC unit the same size with those SEER levels, you're going to see some surprising results. Now, if you go out and price it against something that's inferior, we're obviously going to be challenged on matching that price. So I've spent more time in the commercial side pricing these out, and we compare them to 2-pipe, 4-pipe, and they actually they don't outperform geothermal, but on the operating cost and the energy savings, the payback analysis for geothermal, they actually meet in year 20, between 25 and 30. So when you sit there and look at that these things are comparable to a geothermal on the operating and maintenance cost, and then the capital cost, that's the level we're competing with, is the geothermal world. So as far as like furnaces and regular AC units, we're comparative to geothermal. Like that's the level of energy efficiency we can compare to.
Thank you. And kind of sticking towards the heat pump side is, can Panasonic also do an air to water heat pump solution?
All right. So can we do it today? No. Are we working on bringing it over? Yes. We do have a great award-winning product overseas called the Panasonic Aquaria. We have lined up 2 pilot projects for it. We will be receiving the equipment in December. And of course, we have to put it through the paces.
ULC, CLA, yeah.
Sort of look at it, learn about it more on our end, and then we're looking at certifying it to become available in Canada. And the one that we are bringing over will also be a cold climate down to -28, which is key. It doesn't really work if it's not. So stay tuned on that, and we will be ramping that up as next year comes along and we get some more information and move along with the factory on the production side and certification.
Okay, thank you, Sunny. Seems that there hasn't been any more questions posed. Any more questions from the audience before we wrap things up?
Not hearing any questions. I'd like to thank Patrick and Brian and Sunny for a wonderful presentation today. This was great. This is the cutting edge of housing innovation, and I can see a number of people wanting to find dealers. You have this this information from the deck. Edith, am I right? The recording will be sent out to all of the participants. Is that correct?
Yes, we will share we will share the materials with everyone.
So you'll be able to view it at your leisure, and if you have any questions, I suspect that Brian, Sunny, and Patrick would be just delighted to hear from you. And I want to thank Panasonic for bringing this to the entire community. Shannon, are you there? Well, not hearing from Shannon.
I think Shannon got disconnected again.
Adrian, did you want to thank everybody on behalf of EnerQuality?
Yeah, sure. Thanks a lot to everybody who came out. Hope you found it informative. There will be, as mentioned, the proper documents and contact info and all of that good information that you guys need from the Panasonic team on more information on their products and stuff. I want to thank Brian, Sunny, and Patrick for joining us. And I think that's all for us for now.
One last thing. We had a great response today. We had to cut off participants because we were oversubscribed. We capped things at 100. Our next session will be next month. Owens Corning will be coming and talking to you about all of their innovative systems that they're going to be introducing, or that they've just introduced into the marketplace. So I'd encourage you to sign up as quickly as you can when you get that first email. Don't be disappointed. Thank you, everyone.
Sounds good. Okay. Anything else from the Panasonic team?
Thanks for hosting it, guys. Greatly appreciate it.
I'll second that. Thank you, buildABILITY, EnerQuality, for all your hard work and kind of making this happen. I know we met several times, and I think that first time through it's successful, and I think we're going to get some really good response out of it. Thank you again.
I think so too.
Thank you.
Yeah, take care, everyone. Have a good rest of the week.
Thanks all.